So, good evening, everyone, and welcome to this brand new lecture. We were we are doing refraction, and we were doing the what was the last thing that we did in the last class? I don't recollect. What was the last thing that we did in the last class? Anyone? Do we remember what we did in the last class?
Lens maker's formula.
We were doing lens maker's formula, and we were seeing what happens if we have one medium on one side and other medium on the other side. How we have supposed to find out the focal length of such a lens. One medium is different and the other medium is different. Do we remember how to find out the focal length when the medium are different on different sides? Do we recollect it? Yes or no? Do we recollect it?
Yes, sir.
Yes, sir. So I will start. As I said, I'll give you one problem that you are supposed to do for this one. And this is the problem that I have got for you. So this is depending on what you have done in the previous class. And I hope you have studied in the previous class. So this is what comes from the previous class. You have to find the focal length of this lens. As you can see, the radius of curvature, it is a equiconvex lens. The radius of curvature of both the sides, both the surfaces is 20 centimeters. One side, we have water. Refractive index of water is 4 by 3. Refractive index of glass is 1 by 4, 1.5. And on the other side, we have air, water, glass, air, 4 by 3, 3 by 2, and 1. Both the surfaces are equal. Can you tell me the focal length of this combination? And one more question I am going to ask. Once you do this, I will ask you the second question. First, answer this one. What is the focal length of this combination? This type of question is going to come probably in your JEE Advanced. It also can come in mains if mains paper is a bit tough. Last year, one 8-10 marks question, it came from this chapter lenses. So be careful. They are now giving questions from the lenses part. That is why we are spending so much time. 2 minutes I'll give you. Please solve this. And please do not talk unnecessarily. Do we remember how we did the previous question? If you can remember, you should be able to do this one. 2 minutes, I'll wait. Shall I help you out?
Sir, plus 30 centimeters, sir.
30 centimeters. That is correct. Did you solve it or did you just? Good. 30 centimeter is correct. Well done. Let me give other students time as well. 1 minute for you to solve it. How are we going to get answer for this? So this is the first surface. Let me write the formula for the first surface. What is the formula for the first surface? Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. I am supposed to find out the focal length of this combination of this thing. To find out the focal length of this, I am finding out the second focal length. If I am to find out the second focal length, the rays must come from infinity. Yes or no? So as you can see, these rays are coming from infinity. Do we understand this? Rays coming from infinity, whatever point they meet, that is known as the second principal focus. So let us put the values here. What is the value of?
Plus 30.
Good. Well done. What is the value of mu2 here? Mu2 for the first surface, what is mu2? For the first surface, what is mu2?
3/2, sir.
3 by 2. Well done. Just remember simple thing. 3 by 2 divided by V. Let me write it as V. V by 3 by 2 divided by V minus what is the value of mu1 for the first surface?
4/3.
Well done. It is coming from water. 4 by 3 divided by U. U is taken as infinity because I'm supposed to find out the focal length. That must be equal to 3 by 2 minus 4 by 3 divided by R. What is the value of this refract? This R. What is the value of R?
20.
Plus or minus?
Plus 20.
Plus 20. Well done, because we are talking about this surface and its center of curvature would be somewhere here. This is a convex surface, so R must be positive. Solving this, you will get the value of V. Can someone quickly tell me the value of V so that I don't waste time here? Can someone quickly tell me what is the value of V that you are getting? What is
180,
the
sir.
180 plus or minus, bacha?
Plus, sir.
Plus 180. Well done. Let us move on to the second surface. I will write the formula for the second surface. Mu2 by V minus mu1 by U will be equal to mu2 minus mu1 by R. Quickly tell me what is the value of mu2 here.
1, sir.
Mu2 is 1 divided by what is the value of V? V is the focal length, yes or no? Yes, sir, or no, sir?
Yes, sir.
Well done, sir. Minus what is the value of mu1 here?
3/2.
3 by 2. What is the value of U here? U for this surface is V for that surface. Do we understand this?
180.
180 will be equal to mu2 is 1. 1 minus 3 by 2. What is the value of R, my dear friends?
Minus 20.
Minus 20. You put these values together, you will get the value of F, and I think the value of F that you are getting is going to be 30 centimeters. Do we understand this? Yes or no? No or yes?
Yes, sir.
Anyone got this? Anyone understood this?
Yes, sir.
Please raise your hands, everyone, so that we don't, I know. Girls from this class? Okay. Now, so far, so good. Now, we have done similar problem 2 times, and that tells us that we can actually see something very clearly here, and I can probably create a shortcut to do this. I can probably create a shortcut to do this. So what I'll do is I'll highlight it, and let's see if someone can tell me where I was wasting time unnecessarily. Remember, time is a luxury that I don't have. In the examination hall, I know that you can do this question, but what will make difference is how quickly you are going to do this. How quickly are
F
you
is
going to do
equal
this?
to R by 2 into mu minus 1.
Yes, beta?
F is equal to R by mu 2 into mu minus 1.
How did you get it? Okay, I think you tried. Maybe your answer is correct. I don't know the shortcut one. I can just only see this. And instead of going to this step where I just calculated V, I may not have calculated V. What I could have done is, if I call this equation as equation number 1, and if I call this equation as equation number 2, if I call this equation as equation number 2, and if I would have added them together, what would have happened then? If I could have added them together, what could have happened then? 1 by f will simply come as 3 by 2 minus 4 by 3 divided by 20 plus 1 minus 3 by 2 divided by minus 20. Yes or no?
Yes, sir.
That's it. That's your shortcut, my dear friends. How do I create a shortcut from here? See, I'll just rub this off. I'll just rub everything off. How do I create a shortcut from here? Let me call this as mu1. Let me call this as mu2. Let me call this as mu3. Do we understand this?
Yes, sir.
Let me call the radius of curvature as r1 of this one. Let me call as the radius of curvature r2 for this one. Can you now tell me the formula that you can create? Mu1, mu2, mu3, r1, r2.
mu2 minus mu1 by r1 plus mu3 minus mu2 by r2.
That is as simple as this. Yes. With proper sign convention. Please see that. Because r is positive, r1 is positive, and r2 is negative. Do we understand this? So the formula looks like this, and I will write it on the top here. The formula for 1 by f will be equal to, looking at this, comparing it, mu2 minus mu1 divided by r1, proper sign convention, plus mu3 minus mu2 divided by r2, proper sign convention, and we have the formula for this combination. Do we understand this? Don't have to do all this. You have this. Yes or no?
Yes, sir.
Everyone understands this, sir?
Yes, sir.
Now, see, I don't want you to remember a lot of formulas. But if you can remember it, well, if this question comes, someone might take 3 minutes to do the entire thing. You might just take 15 seconds to do it. And that time that you save is like gold dust. Now, shall I ask you the next question? Shall I ask you the next question?
Yes, sir.
If I change the mediums on both sides, so one side is air, which is the incident side, and the other side is one side is water, which is the incident side. Such type of question come in JEE Advanced. One side is water on the incident side, and the other side is air on the refracted side. If I change it, if I bring air here and water here, remember both the refraction, both the radius are same. Both the radius are same. If I bring air here and water here, does the focal length change or will it remain same?
Remain same.
Water here, air here, a change.
Remain same, sir.
That is the next question. Find out the focal length. So, see it for yourselves. Seeing is believing, my dear friends. That is the next question. And do it fast. Because time is a luxury that we don't have. And remember, time is a luxury that we don't have. This is the question now. Air on this side, water on the other. Which में glass? I hope you understand the problem. Yes or no? No, yes.
Yes, sir.
2 minutes you shall have. Does it change? Does it remain same? And then we will understand if I overlook one simple thing, what happens? 2 minutes you will have. Yes, my dear friends, coming same or coming different? Coming same, no?
Same, sir.
Same. Anyone for same?
Yes,
Yes,
sir.
sir.
But the answer is different. It has to come different.
Sir, 60, sir.
Is it coming same as 60? Or it is coming same?
Before it was 30, sir. Now it's 60.
Before it was 30, now it was 60. No, that is not the problem. The problem
No,
is
sir. That answer is changed, I'm saying, sir.
Sir.
No,
Okay,
if
this 20, sir.
okay. The problem is that the formula that we have made a mistake in the formula. What is the mistake in the formula? Why was this one coming here? Because on the third side we had air. Yes or no? Yes or no?
Yes, sir.
Did we do that thing in the general formula that we created? No, sir. And therefore, now you can see the formula is completely different. Yes or no? Now, answer the same question again. Please correct the formula. If I change it, does the focal length change or does it not change? And the answer now is definitely it changes. Yes or no?
Yes, sir.
Yes, sir. Because this mu3 we did not write, sir. Now, go back. Why did I ask you to write this? Because now I pointed out the mistake and you will never forget this mistake ever in this formula. And this is the mistake that everyone does in this formula. They always write 1 by f. That is the most common mistake in this formula. Do we understand this? Yes?
Yes,
no?
sir.
That is the most common mistake in this formula. Now, apply the formula, get the answer, and stay happy. Apply the formula, get the answer, stay happy. So the formula that we have is mu3 by f will be equal to mu2 minus mu1 divided by r1 plus mu3 minus mu2 divided by r2. Can you tell me the answer now, bacha? Mu3 is 4 by 3. Mu2 is 1.5 or 3 by 2. And mu1 is 1 now. What is the answer? Huh? Everyone calculating it. Arey, the previous answer was 30. Multiply 4 by 3 in that 30. Yaar. That is the answer that you will get. Everyone,
40, sir.
everyone
40.
was getting same, no 30. Now it is not 30. It is multiplied by 4 by 3, nothing else.
40, sir.
40, sir. Okay. 40, sir. That is the answer, sir.
40, sir.
Do we understand the concept, sir? Please don't forget it. If you change the medium on both sides, even if you interchange them, the formula changes. Everyone confident now? Will you be able to do such a problem if it ever comes? Remember this formula, you will not find it in books or whatever notes that you have. You may not find it. Okay? Keep it with you. And I hope that this question comes and you can do it faster than your competitors from everywhere in the universe. Shall we move ahead now?
Yes, sir.
We are doing what? I forgot. We are doing lens makers formula, and remember now is the time that I start cutting things, because this is the time where you can understand what happens if I cut that lens in different parts. Now remember, these type of questions may not come in JEE Main, they may come in JEE Advanced. So what happens if I cut? So we'll write them as important points, cutting of the lens as important points. Now, normally there are two ways in which you can cut the lens. You can cut it along the principal axis. Do you understand principal axis? Tuck, 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 tuck.
Yes, sir.
One of the more difficult question that ever came in JEE, that was JEE of my time. They had cut a lens into two parts and then placed two parts like this, and they are telling you to find out where the image is going to be formed. It's an easy question. That's not is not so difficult. So you can cut it along the principal axis. Now remember what happens when you cut it along the principal axis. So you cut it like this. this lens is cut into two halves along the principal axis. I hope you can see it. What will happen if I cut it like this along the principal axis? Yes, my dear friends, what will happen? Now this may come as an objective question, multiple choice question. What happens if I cut, and they will give you a series of options. If I cut it along this axis, what happens? Yes, it's cut along the principal axis. Let us see what happens. Number one, thus the focal length. So now I have, let us say the focal length of this lens is f. Let us say the focal length of this lens is f1. Let us say the focal length of this lens is f2. What can you say about f1 and f2? Same, equal, different, what? Yes. What happens if I cut the lens like this? What can you say about the focal length f1 and f2? Does it become half of the original length? It becomes twice of the original length. It has got no relation. It remains same. What? So these are the things that you must remember because they can come as multiple choice question. Yes, tell me, what do you think? The focal length f1 is equal to focal length f2 is equal to focal length f. The focal length does not change because as you can see, the radius of curvature here also, the surface was first surface and second surface. The radius of curvature, the surfaces still remain same. Yes or no? So you go on the lens maker's formula, you put the values of R1 and R2, the focal length will still remain same. Do we understand this? Yes or no?
Yes, sir.
What effect does it have on the image? What about the intensity of the image? Does the intensity of image change? Does the intensity of the image change? If this was producing intensity I of the image, what will be the intensity produced by this and what will be the intensity produced by this? Tell me. Intensity of the image. These questions have come in the examination hall in JEE Advanced, so now they can come in JEE Mains. JEE Main, not Mains. Yes, my dear friends.
So 1/4 times.
Well done. The intensity will become 1/4 times of the individual one. Why it becomes 1/4 times? Because intensity is proportional to, well done,
D square.
d square. The diameter has become half. The diameter has become half. So each part has half diameter of the original thing. So intensity, the intensity of the image becomes 1/4. Well done, bacha. Well done. Good. That is what you have to remember. That means you're following the notes. Good. Now there could be a third thing that I could ask. If I have an erect object like this, will the image be halved? Only half image will be formed and half will not be formed. These are the type of question they are going to ask in the examination hall. That time you cannot think. You have to think now. Remember, JEE is cleared in the classroom. It's never cleared in the examination hall. No one clears JEE in the examination hall. Yes. What about the image? Is the image halved? So if I have an object like this, only half of the image is formed. Other half is gone because half of the lens is gone. Yes.
No.
Will the image be full or image be halved? Intensity of image is how intense or how clear.
Full, sir.
Yes.
Full image is formed, sir.
Full image is formed. So remember, these are the three things they ask. They might ask. They can ask. Full image is formed. Full image is formed. Do we understand this?
Yes, sir.
So this will happen if I cut it along the principal axis like this. I'll give you 2 minutes to write it down. Point number 1.
Completed, sir.
The other class, have you done this? Noted it down, bacha?
Completed, sir.
Completed, sir. Then comes the next part. Now, how I'm going to cut the lens? Now, going to cut the lens along the optical axis. Do we see this? Along the optical axis. Now, here I have taken the radius of curvature on both sides as same. Let us take it as same and then we'll make it different. Let us make the radius of curvature on both the sides as same. If I call the original focal length as f, if I cut it along the optical axis, what happens is one side you have r and the other side you have infinity. Do we understand this? Yes or no?
Yes, sir.
Because one side you have plane surface and other side you have curved surface. So in this case, focal length f1 becomes equal to f2 becomes equal to 2f. Do we understand this? Yes or no?
Yes, sir.
Now, if they have different radius of curvature, so you remember, if they have different radius of curvature, my f1 will be equal to mu minus 1 by r1 and my f2 will be equal to mu minus 1 by r2 if they have different focal lengths, if they have different radius of curvature. If they have same radius of curvature, focal length will become twice. If they have different radius of curvature, these are the ratios. They might ask you what is the ratio of f1 by f2. So you can say f1 by f2, the ratio of f1 by f2. Oops, I've written it ulta. It's 1 by f1, sorry. Let me, written it ulta. f1, I always write it ulta, I don't know why. R upon mu minus 1, f2, I always write it ulta. Last class also I written it ulta. Mu minus 1. I always write it reverse, I don't know why. Okay. So if they ask you the ratio of f1 by f2, you can call it as r1 by r2. Do we understand this? This is the first point. The second point is what happens to the intensity I, intensity of the image. Does it remain same or does it change?
Same, sir.
Intensity remains same because I have not cut the aperture. The intensity remains same. What about the image? Will it be half image or cut like this? Obviously, this will not happen. So full image is formed. We all understand this. Full image. This is how if I cut it like this along the optical axis. Do we understand this? Yes or no? Give you 2 minutes to note it down.
Completed, sir.
No, sir, not yet completed.
Don't worry. I will not move ahead unless you give me a go ahead. Trust me on that. Second point, I have cut it along the optical axis. Let me know once you are done.
Done, sir.
Done, sir?
Yes, sir.
Sir.
Now, the third thing is, you might get a question where you have a lens which is made up of different glasses of different refractive indexes. This particular lens has got mu1 on top, then mu2, then mu1, then mu2, then mu1. The question they are going to ask here is, how many images will be formed if I place an object? 1, 2, 3, 5. How many? How many images are going to be formed if I have like this? I have this lens sort of made into 5 different lenses, mu1, mu2, mu1, mu2, mu1. How many different images would be formed?
Sir, 2, sir.
How did you get 2, sir?
2 refractive index.
Yes, well done. That is the concept. 2 refractive indices. Well done. It may be divided into 5 different parts, but if you look at those parts, effectively, it is made up of 2 lenses or 2 refractive indexes. Focal length 1 by f is proportional to mu minus 1. Remember this concept. So, depending on how many different mu's I have, how many different refractive indexes I have, we will have the same number of images. Here we have 2 refractive indexes, mu1 and mu2. Therefore, the number of images here in this case would be 2. Do we understand this? Yes or no?
Yes, sir.
If I change this question and I make this as mu3, if I make this as green, mu3, now the answer would be mu1, mu2, mu3, mu2,
3.
mu1. Now the answer would be 3.
3.
So you count how many number of refractive indexes, how many different refractive indexes are there, and then you give your answers accordingly. Will you remember this? I'll give you a minute to note it down. Remember, all these are potential questions that are going to come. If you're lucky, they might come. If you're not so lucky, they might not come. But you have got so many different sessions these days that it may definitely come in one of those sessions.
Done, sir.
The other class, sir, we are done, sir. Let me know when you are done.
Done, sir.
Done, sir. Okay. Then we come to the next part where I've seen this question examination on. What they do is they cover this by some black paper so that there is a black substance so that there is no refraction from this side. So they cover this entire thing by some black surface, black paper or something. So there is no refraction from this side. And then they ask you what will happen. What will happen in this case? So remember what will happen? Again, I ask you, will you have half image or will you have full image? You will have full image.
Same, sir.
Full image. But what will change if you cover the 1/2 of the lens by a black paper? Intensity will
Change, sir.
reduce. Okay. In fact, intensity will become original intensity divided by 4 because we have covered half of that lens. Do we understand this? Yes or no?
Yes, sir.
Yes, sir.
Well done, sir. Please note it down, sir. Have you noted it down, bacha?
No, sir.
Okay. Let me know when you are done.
So 1 minute. Already I'll know sir. Sir, completed, sir.
What about the others?
Done, sir.
Well done, sir. The next point is regarding what some people call it as chromatic aberration. Now, again, we know that this refractive index by Cauchy's formula is proportional to A plus B by lambda square. Do we remember this? And now I know that 1 by F is proportional to mu minus 1. Yes or no? So if I have white light falling on a lens, it was falling on a prism, we were having dispersion. If it falls on a lens, it consists of different wavelengths. The wavelength of red is more than the wavelength of violet. Yes or no? But
Yes.
wavelength is inversely proportional to mu, and focal length is also inversely proportional to mu. Yes or no? Therefore,
Yes, sir.
what you will have is for different light, you will have different wavelengths. For different light, you will have different focal lengths. Focal length for the red will be more than focal length for violet, and therefore, if white light is coming from infinity, violet light will get focus at the nearest point, and red light will get focus at the farthest point. The other light will get focus at different points between violet to red, whether it is a convex lens or it is a concave lens. Do you see this, bacha? Everyone understands what I've written here? Yes or no?
Yes, sir.
Please note it down. All these are potential questions that are going to come in your examination hall. Please note down these important points. You will not find them. Shall we move on to the next point? Have we done it, bacha? Now?
Done, sir.
Completed, sir.
What took you so long? You were doing it so quickly now. Anyways, this is the next case where we have a sunglass. Now what happens in sunglass? Both the radius of curvature are equal. But if you look from one side, if one is convex, the other one is concave, they have their center of curvature on the same side. R1 become equal to R2. Therefore, power for such a lens, it is not a lens anymore because the focal length becomes infinite and the power becomes 0. This is how sun goggles are made. If you have both the surfaces of same radius and they have their centers on the same side, you will have a lens whose power is going to be 0. Do we understand this? Yes or no?
Sir. Yes, sir.
Please note it down. And then we will move on to the next heading. I'll give you 2 minutes to note it.
Completed, sir.
Not yet, sir.
Do it, sir. Don't worry, I will not move ahead unless you'd say, yes, sir, we are done, sir.
Noted, sir.
Shall we move ahead now, everyone?
Yes, sir.
Okay, sir. Then we come to the next heading. And the next heading is known as your sign convention. Sign convention for your lenses. Now, this is nothing new. We have already done it. So we will just go through it quickly because all of us know it beforehand. hand. Now I might be showing it for a convex lens, but whatever be the type of lens, this convention holds true. So this is the lens that I have. What do is I make this optical axis and then I make this principal axis. Okay. This is that is called the center, optical center C. What is the first thing that you must remember about the sign convention? Number one, tell me. You know it, so you tell me. Tell me fast. What is the first point? All distances are measured from
Measure from the center.
all distances are measured from the optical center. Well done. Optical center. I am calling it as C. Now let us assume that the object is here. So my incident light is coming like this. Yes, what would be the next sign convention? Which direction is treated as positive? Direction of?
Incident rays.
Direction of incident ray is taken as positive. That means in this case, everything on the right of C is positive, everything on the left of C is negative. Do you understand this?
Yes, sir.
But remember, in the lens, in mirror, the ray was coming always from the left hand side. But in case of a mirror, the ray can also come from the right hand side. If the object is placed on the other side, ray will come from this side. In that case, everything measured in this direction would be positive and everything measured in this direction would be negative. Do we understand this? It will not happen very frequently, but it can happen. Do we understand this?
Yes, sir.
So, remember it. The direction of incident light is taken as positive, not the left or the right. In case of mirror, you could say left, right, left and right because light was always coming from left. Here, light can also come from right. What is the third thing that you must remember? Distance is measured up from C are taken as positive. Do we understand this? Yes or no? No, yes.
Yes, sir.
Now let us see if the question is like this. Let us find out. This distance will be known as what? The distance of the object from the center C will be known as what? This would be known as U. The distance of the object from the lens. Now, put out this sign convention that we have written and tell me, is U going to be positive or U going to be negative?
Negative, sir.
Negative, sir.
Well done, sir. Good. Let me imagine that the image is formed at this point. So this distance would be known as the distance of the image, V. Can you now tell me, according to the sign convention, if this is the case, is V positive or is V negative?
Positive.
Negative, sir.
Negative? Beta, V will be
Positive,
measured in
sir.
this. It will be positive. Yes or no? No, yes. Yes or no?
Yes, sir.
Now tell me here, is this object real or is this object virtual?
Real.
Is the image real or is the image virtual? This object is real. What about the image? Is it real or virtual? Remember,
Real, sir.
remember for a lens, whenever image is formed on the other side, it is always going to be real. Do we understand this? Okay. Now
Yes, sir.
tell me, this is what type of lens? This is a convex lens. will the focal length of this lens be positive or negative? Is the focal length of this lens positive or negative?
Positive, sir.
Positive, sir. If I place the object on the other side, will the focal length be positive or negative?
Positive.
No matter where you place the object, the focal length of a convex lens will always remain positive. It can only change if you change the medium. Do you remember it? It cannot be changed by changing the object. You place the object here, it is convex lens. You place the object there, it becomes a concave lens. No, that does not happen. Do you remember this? Do you understand this? Yes or no?
Yes. Yes, sir.
Let us say that the height of the object is HO. I hope you can see HO. Is HO positive or is HO negative? Is
Positive,
HO?
sir.
Well done. Now we are talking. Good. Let us look at this HI, height of the image. Is it positive or is it negative?
Negative, sir.
Well done, sir. Do we understand the sign convention, sir? I'll give you 2 minutes to note it down.
Completed, sir.
Not yet, sir. అయిపోయింది, sir.
Done,
అయిపోయింది,
sir?
sir.
Done, sir?
Yes, sir. Done, sir.
Okay, sir. If we have done this, sir, sign convention is okay, sir. Then we move on to the next heading, sir. What would be the next heading? Huh? What is the next heading? The first formula that we saw in reflection was the mirror formula. Now comes its counterpart, and that is known as not the lens maker's formula, it is known as the lens formula. Lens formula. And I hope all of you know this lens formula. So quickly tell me what is the lens formula. Remember, this formula is only valid if one side you have air and the other side you also have air. Do we understand this? It's only valid for air on both sides. So what is the formula? Tell me, fatafat.
1 by V minus 1 by U equal to 1 by F.
1 by V minus 1 by U is 1 by F. That is as good as it gets. Well done. So now it looks like everyone is paying attention and everyone is studying. Well done. Good job. 1 by V minus
The
1
proper
by
sign
U.
ఉంటుంది.
Yes, beta? Did you say something? Did I miss it?
Nothing, sir.
Nothing, sir. Okay, sir. 1 by V minus 1 by U is equal to 1 by F. Remember, this formula has to be used with proper sign convention. U, F, V. Remember, for a convex lens, focal length is always going to be positive. For a concave lens, focal length is always going to be negative. We understand this, yes or no?
Yes, sir.
Yes, sir.
Okay. I hope we keep our enthusiasm a bit on the lower side. That would be good. Okay. What is the next heading? Once we see this formula, the other thing will be known as magnification. Do we understand magnification?
Yes, sir.
Magnification. As soon as we hear the word magnification, we must understand that there will be two types of magnification. What is the first type of magnification known as?
Lateral and transverse.
Lateral or transverse, bacha. So they are the two names of the same thing, lateral or transverse magnification. Lateral or transverse magnification. What do you mean by lateral or transverse magnification? It's the same magnification that we had seen. That magnification MT or ML, or let me call it as MT, that would be good because you can use L for the longitudinal one. MT, that is equal to height of the image HI divided by height of the object. Do we understand this?
Yes, sir.
Everyone, well done. Okay, now we can easily say that in case of a mirror, this HI by HO was coming as minus V by U. In case of this lens, it will come as plus V by U. It will come as plus V by U. Please note it down. Now I can substitute in place of V, I can substitute it in terms of F and U. And remember, I told you in the class on reflection as well, if you can remember these small shortcuts, you can do some questions really quickly. So F upon F plus U, that is another way of writing the same thing. Or you can write it as F minus V divided by F. All these things refer to the same thing. Transverse magnification. Remember, whatever formula we are making here, my dear friends, all are to be used with proper sign convention. Do we understand this? Yes? No? Do we understand this? With proper sign convention.
Yes,
okay, then we can write some important things here. If magnification, okay, let me just write it this way, probably. If magnification is less than 0, or we call it negative, then the image is real. Yes or no? If
Yes, sir.
magnification is greater than 0, or we call it positive, the image becomes virtual. We all understand this. Yes or no?
Yes, sir.
Yes, sir.
Okay. If the magnitude of magnification is greater than 1, we call it enlarged. Yes or no? I think it is going to go away. Things happen in life which we don't have any control over. So let me get it back. Okay. I hope you can see it again.
Yes, sir.
If magnification is greater than 1, we call it enlarged. The magnitude I'm talking about. If the magnitude of magnification is less than 1, we call it diminished. Do we all recollect this? Do we all remember this? We have already done this in great details in the in the topic of reflection, and therefore I'm just giving you all these things together. I hope you don't mind it. Yes or no?
Yes, yes, sir.
Yes, sir.
Please note it down, sir.
Completed, sir.
IITians, sir.
Done, sir.
Yes, sir.
Then what is the second type of magnification? Please tell me, bacha.
Longitudinal magnification.
It is known as longitudinal magnification. Let us see how many of you remember it. Yes. Let me call it as ML. Now tell me, bacha, what is the definition of ML? How do I find ML? Now the object, instead of placing it erect, I will place it along the principal axis. Along the principal axis. So how do I find the magnification? I will found it like this. Length of the image Li divided by Lo. Do we remember this?
Yes, sir.
So I can write it as V2 minus V1 divided by U2 minus U1. Yes or no? Distance of the two endpoints, image ka endpoint minus distance of the object ka image point. Yes or no? Remember this?
Yes,
Yes,
sir.
sir.
Then we had written it for small objects, and this is the point that comes in exam, not big objects, but for small objects, I can write this ML as dv by du. Do you remember this? Small change in v for small change in u. And this will come as v by u ka square, or you can write it as f upon f
M square.
u ka square. Well done. Now we are talking. Well done. Good. I'm really impressed. F minus v by f ka square, or you can simply write it as transverse magnification ka square. I hope all of you remember this. Even if you don't remember it, this is a quick revision of your chapter on reflection. I'll give you 1 minute to note it down.
12 minutes approx. 12 minutes.
Completed, sir.
No, sir.
No.
हो गया सर.
Completed, sir.
Okay, sir. Then, in some very difficult cases, they can ask you the third type of magnification, that is known as areal magnification. Do you remember magnification in area?
Yes, sir.
Areal magnification. And how do I find this areal magnification? I can call it MA or MS, superficial magnification. This is area of the image divided by area of the object. Yes or no? And we get the same formula. It will be transverse
Square.
magnification square, V by U ka square, and all those things. I am still writing it once more so that more times I write it, the better are my chances of remembering it, because tell you very frankly, I hardly remember it many times. Areal magnification.
అమ్మ ఎవడ దిక్కున్నాయి ఏ కంటే దిక్కుంటు
Are we done, bacha?
sir.
Shall we move? Return the areal magnification formula.
Completed, sir.
Well then, you can write one more formula, relation between object and image speed. Relation between object and image speed. If you recollect, bacha, we had seen the same formula for a lens, for a mirror. Do we remember it? Do you remember it, bacha? We've seen the same formula for a mirror. The relation between object and image, the relation between object and mirror, object and image speeds. Do you remember that formula, bacha? Anyone remembers it? No one seems to remember it. Okay, so let me make a case. This is my optical axis and this is my principal axis.
2 VM equals to VI plus VO.
That was for the plane mirror, beta. That was for the plane mirror, yes or no?
VI equals to magnification of
VO.
Yes, that was when it was moving perpendicular. You know? What about it moving parallel? Yes, I guess you remember it. So if this is an object O and it is moving with a velocity VO, it is moving with a velocity VO, the image will move with a velocity VI. Can you tell me the relation between VO and VI? VO and VI. Yes, my dear friends, VO and VI, when it is moving along the principal axis. So remember, the formula is still same. VI is transverse magnification square into VO. You can write it as V by U ka square into VO. You can write it as F upon F plus U ka square into VO. You can write it as F minus V by F ka square into VO. Do we understand this? Yes or no?
Yes, sir.
Okay, sir. I'll give you 1 minute to go through this. And remember, I think we had done a question. The question that came in JEE, it was based on this. And here this VI, remember this VI is the velocity of image with respect to what? That was the thing that was, I did not tell you. And the question that came in JEE Advanced was based on that thing. This VI is the image of, is the velocity of image
With respect to lens.
Well done. It is the velocity of the image with respect to the lens. Similarly, this VO is the velocity of the object with respect to the lens. In normal cases, lens does not move, but in the question that was there, the lens was moving. Remember, it is simple to understand because this VI and VO, or this I and O, V and U, they're all calculated from the center of the lens. So if the lens moves, everything moves. Do we understand this? Yes or no? That takes us to the first question. Can I get you the first one?
Yes, sir.
Okay, sir. Let me see where is the first one. I don't see it here. Okay, then I must get it from here. Okay, this is the question for you, and I think this is from your that module itself, and I'll give you from the module itself. I think the question number is 57, I guess, and this is the question that you have. Question number 1. It encompasses everything that we have done till now. Let's see if you can do this. You can take this homework as homework if you can't do it in the class now because the time is running out. An extended real object of size 2 centimeter is placed perpendicular to the principal axis of a converging lens. So height of the object is 2 centimeters. It is placed perpendicular and the lens is converging, whose focal length is given as 20 centimeters. The distance between the object and the lens is 30 centimeters. So things are given. Number 1, what is the lateral magnification? Number 2, what is the height? Find the change in the lateral magnification if the object is brought closer to the lens by 1 mm along the principal axis. Let's see who gives me the answer.
Sir, MT equals to 2 by 5.
Two by 5. Sign convention, my dear friends. Every formula has to be used with proper sign convention. Please don't forget it. So quickly, I can do it in a variety of ways. What is the quickest way that I have? MT, the transverse magnification, is equal to F is given, U is given. So let me put the formula F upon F plus U. Just so yes. F is plus 20. How much is the value of U, my dear friends? U minus 30 beta. And therefore your answer will come an astounding minus 2. Do we understand this? Yes or no? No, yes.
Yes, sir.
How many of you got this answer? Please raise your hands so that I understand that we understand that
Sir, once repeat again.
U, the object distance is negative now, beta. U is negative. It's a real object. We have to use the formula with proper sign convention. Do we understand this? We have to use the formula with proper sign convention. We understand this. Got it?
Yes, sir.
Converging lens, focal length is positive.
Okay, sir.
U, object distance is negative. The magnification is minus 2. Now to find out the height of the image divided by height of the object is the transverse magnification. That implies height of the image is transverse magnification divided by the height of the object minus 4 m, not cm, centimeter. Is it a real image or it is a virtual image? It is a real image. Do we understand this?
Yes, sir.
The third part I will give you as homework. We will discuss it in the next class. Third part is given to you as homework. The question is there in your module. You can have a look at it. We'll discuss the third part in the next class. We'll wind up this class here. On this note, we have done a lot of things in today's class. We have seen the lens formula. We have seen the different magnifications of the lens. We have seen the sign convention. We have also seen what happens if we cover one part of a lens, if you make lens of different materials, if you cut lenses. All these are potential questions, and I hope that you can remember them. I hope everyone has written notes. Yes or no?
Yes, sir.
Okay. From this particular class, you might find a couple of questions coming in the examination hall. So remember it. I'll see you in the next class. If you have any doubts, you can ask me. Take care. Have a nice day. Bye-bye.